The universe might be hiding a massive secret that's driving cosmologists absolutely crazy. And it's not what you think. Here's the mind-bending reality. Scientists are facing one of the most perplexing mysteries in modern astronomy, known as the Hubble tension. This isn't just some minor measurement error. It's a fundamental disagreement about how fast our universe is actually expanding right now. And it's shaking the very foundations of our understanding of cosmic evolution. Imagine trying to measure the speed of a car using two different methods, only to discover that one method consistently gives you 60 miles per hour, while the other insists it's going 70 miles per hour. That's essentially what's happening with our universe's expansion rate. When astronomers look at ancient light from the early universe, specifically something called the cosmic microwave background radiation, which is like the universe's baby photo, they calculate one expansion speed. But when they measure nearby galaxies and stars in our modern cosmic neighborhood, they get a completely different, faster rate. This discrepancy emerged prominently in 2022, and here's where it gets truly unsettling. Instead of resolving over time, this cosmic contradiction has only grown more pronounced. Scientists have been desperately searching for explanations, turning over every theoretical stone they can find. Now, here's where things get controversial. The standard models that cosmologists rely on operate under a fundamental assumption that the total amount of matter in the universe stays constant over time. But what if that assumption is wrong? What if matter is actually vanishing from existence? Several theoretical physicists have proposed that dark matter, that mysterious substance that makes up roughly 85% of all matter, but remains completely invisible to us, might be slowly decaying into some form of undetectable radiation. The problem? We still have absolutely no clue what dark matter actually is, making these theories educated guesses at best. But here's where it gets fascinating. There's actually a proven, observable way that matter gets completely destroyed in our universe, and it's happening right under our noses. Black holes, those cosmic monsters that devour everything in their path, provide a genuine mechanism for matter annihilation, but not in the way most people think. Contrary to popular belief, when matter falls into a black hole and crosses the point of no return, called the event horizon, it doesn't actually disappear. That matter still exists. It's simply locked away forever, hidden from our view. However, when two black holes collide and merge together, something extraordinary happens that most people completely miss. During these cosmic crashes, an absolutely staggering amount of mass gets converted into pure energy in the form of gravitational waves, ripples in the fabric of space and time itself. We're talking about the equivalent of several entire suns' worth of mass being transformed into energy and set rippling across the universe. Once this transformation occurs, that original mass is gone forever, genuinely removed from existence. These gravitational waves aren't just theoretical. We can actually detect them using incredibly sensitive instruments like the Laser Interferometer Gravitational Wave Observatory. And we can observe their effects indirectly through pulsar timing measurements. This represents a verified, scientifically confirmed method for permanently destroying matter in our universe. So here comes the million-dollar question that has researchers divided. Could these black hole mergers be happening frequently enough to account for the Hubble tension mystery? A dedicated team of astrophysicists at Vanderbilt University recently tackled this exact question, and their findings might surprise you. They conducted detailed calculations to determine exactly how many black hole mergers would need to occur to destroy enough matter to resolve the Hubble tension. The results were sobering. To eliminate sufficient matter to explain the discrepancy in expansion measurements, black holes would need to be merging at rates that are simply unrealistic given what we observe in the universe. Here's the mathematical reality. Scientists can estimate the actual rate of black hole mergers by analyzing how many massive stars form throughout cosmic history, calculating how frequently these stars die and collapse into black holes, and determining how often these black holes actually encounter each other and merge. When they crunch the numbers, the actual occurrence rate of black hole mergers turned out to be approximately 10,000 times lower than what would be required to solve the Hubble tension. Even accounting for significant uncertainties in their calculations, and the possibility that merger rates might be higher than estimated, the gap remains enormous and insurmountable. These findings, detailed in research submitted to the ArcFID preprint database, though not yet peer-reviewed, effectively rule out black hole mergers as a solution to this cosmic puzzle. But here's what's controversial about this whole situation. While this research eliminates one potential explanation, it actually makes the Hubble tension mystery even more intriguing and problematic. We're left with a fundamental disagreement about the nature of our universe that refuses to go away. And we're running out of conventional explanations. Despite not solving the mystery, this research represents exactly the kind of methodical detective work that science demands. When confronted with any cosmic puzzle, whether monumental or minor, scientists must systematically examine every conceivable possibility and investigate every potential lead. Only through this patient, persistent, and rigorous approach will we eventually uncover the answers to our most challenging and elusive mysteries. And this is the part most people miss. Sometimes the most valuable scientific discoveries come not from finding solutions, but from definitively ruling out possibilities and narrowing down where the real answer might lie. So what do you think? Are we missing something fundamental about how our universe works? Or is there an even more exotic explanation waiting to be discovered? Could there be other mechanisms destroying matter that we haven't even considered yet? The debate is far from over, and honestly, that's what makes this mystery so compelling.